All right, so now I want to talk about something fun. I want to talk about color output, putting color on your terminal. What am I talking about? We'll take a look at this. Notice how Dave and YSAP is colored. We have a nice little blue color here. We have a green color here. If we were to pull up some commands, I think earlier I pulled up htop. You can see that there's a whole bunch of color going on here. How do we get that? Well, I'm going to show you the basics of color because we can use it in Bash. This is not a Bash specific thing. You can do this in any language. I'm going to show you how to use Bash to create these sort of color codes. So let me explain that if you've never seen this before, imagine we were writing HTML for a website, okay? You might have something like this where I can say, what was it, bold? I don't think people use the bold tag anymore. This is very old, but let's say we're using a bold tag or B for bolding your stuff. You could say, this is bold. And then you close that B tag, and there you go. This is how you do it in HTML. This is how you instruct your browser to make that text bold. This doesn't work on a terminal, obviously, but there is a way we can instruct our terminal to make the text bold. The way we do that is by using something called ANSI escape sequences. Here is what I'm saying, ANSI escape sequences. And we do that by using the escape character, which is a specific byte that we can emit to the screen. And then we put some other text after that, and then we close that sequence. So basically how we did this, you can think of the escape character as this less than sign, and the rest of this is the sequence. That's not exactly what it is, but I'll show you what I mean by that. All right, so if you don't know what I'm talking about, I'm gonna pull up a web page here real quick. So in order to talk about that, we have to talk about the ASCII table. So these are ASCII characters. There's a lot of history here. There's a lot of stuff I can get into here. I don't have time to really talk about all of this. It's kind of outside of the scope of this course. But what you need to know is there are 256 possibilities here. So another way of saying that is 256 possibilities. That means there are 8 bits. You can see what they look like in binary here. Or there is 1 byte because there are 8 bits to a byte here. Now, there were 128. Now there's 256. They all fit comfortably into a byte. It might even go beyond that. There's like ASCII and then extended ASCII. There's a whole rich history there. Like I said, I don't have time to get into it. But let me show you just a quick example. Like if I wanted to print the letter A to the screen, I actually have to write this binary, this single byte. It takes a whole byte to print the letter A. Or I could print the number 141. No, that might be octal. The number 97. Or I can print 61 in hex. So this is a hex number right here. So you can see like 5F, 60, 61. So that might be a little bit confusing, but if I emitted hex 61 to the screen, I would get the lowercase a letter. And then if we scroll up, we did this before earlier in the course, I emitted 0A if you remember. If we scroll up here to 0A in hex, you can see that that emits a line feed. That is the new line character. So let me go pull up the terminal real quick. So on the terminal, we can use printf. We did this previously to print raw bytes to the screen using %b as the format specifier. Technically, we don't need the quotes because there's nothing special with %b, but I just put them here to let you know that this is a format specifier. This is just a raw string. Printf is taking the string in, and then it will format the arguments so it will interpret backslash. So I can do \x for hex, and then I could say the letter A, which was 61, and then close that. Then I could do it again, because remember, printf will repeat the format specifier for each argument we give it. We could say 0A. So if this works, we should print the lowercase a and a new line. And there we go. We get the lowercase a and a new line. We could prove this. We could pipe it to XXD, and we just get 61OA, which makes perfect sense. We have 61OA. So that's what's going on there. This is important because now we can print characters that are unprintable. There are certain characters that have a special meaning but don't actually show up in any sort of meaningful way on the terminal. So let me go back up here and show you a character on the website. This one's going to be super useful. If we scroll up, we're going to see right here, the printable characters start at hex 20. Above that are the unprintable characters, and there's a lot of weird stuff here. We've seen some of them. We've seen things like horizontal tab. We've seen line feed, which is like the new line. We've seen vertical tab. We did a \V for that. There are some interesting ones here. The one that we care about is 1B. I just happen to have this memorized because I use it a lot. 1B is what we care about. Hex 1B. It is the escape character. So it's 1B in hex, it's 33 in octal, and it's 27 in decimal. So I will show you what that looks like. If we wanted to print the escape sequence, we could do printf %b, and then the same notation here, 1B, and then it won't actually print anything. Nothing will show up to the screen because it's unprintable. But if we pipe it to XXD, you can see there's a 1B there. Okay, cool. That makes sense. We can also give it octal if we wanted to. So 033, I think it was what it was in octal. Oh, nope. It's trying to convert that to a word. So I actually have to do this notation. There we go. So, yep, so same thing. We can give it the same kind of notation, but this time it's octal, but we still get 1B there. And the other one was the decimal notation. I actually don't know how to do that. I don't think you can just do that. Yeah, so it just assumed it was octal. I don't know how to do a decimal representation like that with printf, but you never really are going to use that because bash has a special character that is built in that we can use, which is \E. So as long as we use that, that is the escape character. That's built into bash. We don't have to worry about it. \E means the escape character. But that's just the character. So like in my HTML example, that would just be the less than sign. We still need the bold and we need to close the actual HTML sign here. So we're going to do that now, but it's not HTML. Remember, we're going to put a sequence here that tells it to be bold, and then we're going to close it. So let's tell it to be bold, and then let's close it. There we go. So now I can just printf bold like that. And then I print it, and there we go. It prints bold, and that text is actually bold. I should probably put a new line here so it's easier to read. Hey, that's really cool. That text is bold. Now, the funny thing is this text, as you can see, is also bold, but it's not bold up here. So we never actually closed the bold. Think of it like this. We opened up a B tag for bold text, but we never actually closed it. That's the HTML example. So let's go ahead and close it. We do the same thing. We need an escape character, which starts a new sequence, and then we will reset it. So instead of 1, we're going to give it 0, and then M to close the escape sequence to say that we are done. So if we have this, now we have bold. We have bold text here. So we have not bold, space, 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 and then bold over there. And you can see, hey, we have bold text in the terminal. That is really amazing. Now the terminal, when I say my terminal, I don't mean bash, I mean my terminal. This program that I'm running, iTerm2 on my Mac, is what's responsible for interpreting that. Oh, cool. I accidentally cleared my terminal. Yep, sorry about that. So my terminal, the program, is responsible for interpreting that. What bash is actually outputting, so there's a lot going on here, but as you can see, bash is outputting all of this to the terminal, and the terminal's rendering it. So we have 1B, which is our escape sequence. We have 5B, which is the open square bracket. We have the number 1. We have the letter M, and then we have we have BOLD. So these 4 characters are BO and LD. The actual character's bold. And then we have, of course, our 1B here, which is our escape sequence. And then we have the standard 0. You don't need to memorize all this. You don't need to think about all this. This is just an easy way to debug it. Let's not use the hex viewer because that might be a little bit confusing to people. We can get bold this way. That is super cool. There are some other sequences we can do which are really neat. Instead of 1, what if we gave it 33? Okay, it says bold, but it's not actually bold. What if we called it yellow? Look at that. Now we have yellow. How cool is that? So I'll show you some more examples, but before we get into that, I want to show you that you can also store the escape sequence. Just like we've stored other characters before, we could do something like escape equals, and then we can do this special string notation. We could put the E like this, and now we are free to use it inside echo, which is cool. So we could say something like escape, and then it's the open square bracket 1M bold, and then we could do escape open square bracket 0M to close that, and we run it and we get bold output there. So that is pretty cool. Same thing, we could put 33 here. We can get yellow. It says bold, but it's still just yellow, and the 0 still actually properly closes the color, so we don't have any color leaking over into the next command that runs, which is pretty cool. I see a lot of code out there. In fact, I even use code like this where I generate my website. If you haven't seen my website before, I'm surprised I went this far into the video without showing it. ysap.sh, you suck at programming.sh. If you curl it, my website renders in the terminal. It's pretty cool. I have a whole video dedicated to how I make this, so of course that'll be linked in the references. But as you can see, there's a lot of color code stuff happening here. So there's a lot of escape sequences being opened, a lot of color stuff. There's even some italics going on. You can get very, very fancy with the code, and it's really, really cool. If I were to pipe this to XXD, there would be a lot. I'm not going to go through all of this, but feel free to take a look at it sometime. There's a lot going on there. So like HTML instructs your browser on how to format things, ANSI escape sequences instructs your terminal on how to display things. That's a good way of thinking about it. There is another thing you can do. You don't have to hard code these commands. This ANSI escape sequences, I find they work for most terminals out there. Most modern day terminals will handle them just fine. There is technically a command. This is not a fully portable command, meaning it might be different on different operating systems. I've had some issues in the past where FreeBSD's arguments to tput was way different than Linux's arguments to tput. I think for the most part, they're pretty similar now, but still, I've been burned by in the past, so I just kind of put all my ANSI escape sequences in myself. I just write them myself, but you can use tput as well. Tput makes things very easy. Take a look at this. Tput bold, and this just prints the bold thing to the screen. Now, nothing was after it, but watch this. Echo hi. There we go. High is bold. And then we can do a tput reset. Don't actually write reset, right? SGR0. There you go. Tput reset, I think, does exist. Yeah, that'll just reset your terminal in case you get into a weird situation, or if you mess up your terminal, you can run tput reset, or your system might even have a reset. This doesn't reboot your computer, don't worry. This just resets your terminal in case you get like weird color, or your cursor's in a place you don't expect and things got all messed up. Reset command is a lifesaver. But yeah, with tput, we can do all sorts of things. So remember how I used that color 33? Well, I can actually do tput set AF3, echo high, tput SGR0, which is the reset, and it says high. So yeah, no trickery going on here. If I were to do, what was it, tput bold and pipe that to XXD, you can see that it's doing the same thing. It's still giving me the escape sequence 1M. So it's the same exact stuff because my terminal supports this. Tput might be better at supporting other terminals out there. It's outputting something slightly different. I'd have to look in to see exactly what this is doing. This one's not exactly what I thought it'd be, but that's interesting. Set AF3 was to change the color to yellow, and as you can see, it just does 33M. Now I'm using 33. You could really use anything you wanted there. We have, let's change this to, instead of yellow, we could change this to 30M and just put color here. And we can see that we can't see it. That's because it's the black color. Then we have red. 32 will be green. 33 we've already seen as what? Yellow. 34 is cyan? No, blue. Oh man, shows how much I know. Magenta? Hey, got it. 36 is cyan, isn't it? Nope. I should stop. Oh no, it is cyan. That is cyan, right? Am I crazy? I don't know. I should just stop guessing. There's like 8 colors you can use here safely. And then there's an extension, which gives you 256 colors. And then there is another extension, which gives you like, what is it, 24-bit coloring, so like roughly 16 million colors. You can basically do hex red, hex green, and hex blue if your terminal supports it. I'll show you all that stuff. It can get a little bit confusing here. But yeah, we have like our colors are here, so we can do like 32 and now it's green. You could change this to 42, and now we've set the background color. So you can totally do that. You can change the background color. You can reverse the foreground and the background color. There's all sorts of magical, fun things you can do with colors here. I am just scratching the surface with it. There is, like I said, let's talk about the 256-bit color. This one's pretty cool. We do the escape sequence. We open this up, and we do, instead of like 33, we do 38, but now we put a semicolon here, and this next one tells us what color mode we are in. So let's do 5, and now we are in 256 color mode. So we can do 256 colors. So we have the number 0 all the way up to 256. So we could do something like that, put the M there to close it, and we could say color 0. And then let's go ahead and reset this and bring this back to done. Let's put a new line in there so it's easier to read. I know these printf commands can be kind of hard to understand, but hey, look at that. That's what color 0 looks like. This is what color 1 looks like. We still wrote out color 0, so it's a little bit confusing. But I have 256 colors, so I can put a large number of things here. So in fact, let's go ahead and make our own little color script. So let's cd into our foo directory. We are in our home directory, foo. Let's go ahead and make a script called 256 colors. Okay, user bin env bash. There we go. Let's back out of this. Go ahead down here, and we can do, let's just make it, what should we do? Let's do for I in 0 all the way up to 255. This is every single possible color. There are 256 possible colors, 0 through 255. And let's go ahead and printf the same thing we did before, which was the E, the 38 semicolon 5, the number, which we can use %D to put a number in there. And then we can put an M to stop it. Now we can say color %D, put the number in there again, put a new line here, and then let's go ahead and reset that with a nice 0M. All right, and that should be good to go. I think that's all we need. Let's go ahead and put the new line after the reset. Doesn't really matter here. And we're using the same number twice, so we only have to supply it as an argument once, which is kind of nice. This should be good enough. Let's go ahead and test this. I normally have notes that I can look at a little bit and kind of get an idea from running this. I'm writing this all by scratch, so we're going to see if this works. Let's go ahead and clear the screen and run it. Hey, that looks pretty cool. I don't love that it prints color 0 every time, so something didn't quite work there. Oh, this was my mistake. This is what I get for trying to code on the fly like this. You actually have to pass the argument twice. I got confused. I said that we have multiple things in this printf, but we only passed one argument. That's not okay. The opposite is true. If we only had one variable mentioned in the format specifier, we could pass multiple arguments. This is the opposite situation. We're mentioning a number twice, so we do have to give it twice. So my bad there, $I. Now we'll run this, And there we go. There's our beautiful 256 colors. So you also have this color palette to choose from, which is really neat. On top of that, there is also another one which your terminal may or may not support it, which is RGB true bit coloring. It's 24-bit coloring. All right, so to do this is printf, open up that escape sequence, open up this square bracket, and it's 38 semicolon 2, not 5 this time, 2. And then here we can do R, G, and B. And that's what we can do. We can specify a certain number of R, a certain number of G, and a certain number of B. So I will do %D, semicolon, %D, semicolon, %D, M to close it. And we can just say color, LOL. Like, it doesn't really matter what it is. So, and then let's go ahead and reset this with a 0M. We'll put the new line there. And now we can give it an RGB value between 0 and 255. So if we give it all 255, this should be white. There we go. Hey, that's awesome. If we turn down some of the blue, so we have red and we have green and we only have a little bit of blue, look at that, we get yellow now. If we bring that down to 0, then we have a more pronounced yellow. So you can mix and match. You could put like 45, 45, 90, and you can just start mixing colors together and get the exact color you want. If you know a hex value you want. If I wanted something very red, 255 red, a little bit of green, like 100 green, and just like a tiny bit of blue, give it like 60 blue, then there you go, you get a color like that. So yeah, my terminal supports it, your terminal may not support it, but this is how to use ANSI escape sequences to actually output color to the screen. There's way more you can do with this. You have bold, you have underline, you have italics and stuff. What I like to use, my reference, I've mentioned this before in a previous video, my reference is this gist, which I will link in the references at the end of this course. This gist is amazing. I love it. It talks about, it is a cheat sheet for every single thing you can do. So it talks about like the colors and stuff. It gives you the whole palette here. You can scroll down, you can learn everything about it. And there's way more that you can do with ANSI escape sequences. You can like move the cursor around and stuff like that. So there's a deep rabbit hole here.